When you think about it, the concept of physical change in chemistry is truly fascinating. Take, for example, the different states of matter: solid, liquid, and gas. Each state is determined by the energy levels of the particles within the material. When a substance changes state, it is known as a physical change. As a material gains heat energy, its particles begin to move more rapidly, causing the material to change from a solid to a liquid and eventually to a gas. This process is known as melting and boiling, respectively. When a solid is heated, its particles gain more energy. When they have gained enough energy, they are able to move out of their positions more freely. This is when melting occurs. If we continue to heat the liquid, at a certain point, the particles have enough energy so that they are able to break the forces holding them in the liquid formation, turning it into a gas. As a material loses heat energy, its particles slow down, causing the material to change from a gas to a liquid and eventually to a solid. This process is known as condensation and freezing, respectively. These graphs are heating and cooling curves. The heating curve shows how increasing heat affects the state of a substance. When materials are in the process of melting or boiling, there is no temperature change as the energy is being used to weaken the forces between particles. The cooling curve shows how decreasing heat affects the state of a substance. When materials are in the process of condensing or freezing, there is no temperature change as the energy is being used to strengthen the forces between particles. It's incredible to think about how the simple addition or removal of heat energy can completely alter the physical state of a material. The particles within the material are constantly in motion, reacting to changes in temperature and energy levels. It's like a delicate dance where the slightest shift can cause a dramatic transformation.